So I wanted to present a little bit about the IoT and how it works with blockchain, because as David just mentioned, blockchain is interesting, but it always comes to the physical world. So how do we incorporate the physical world into the blockchain? So I'll just begin with a little bit the sad state of affairs. When you read the news, every single day you read something really sad about how corrupt our blockchains, how corrupt our supply chains are. You always have people being affected by bad quality products or contaminated products, and especially medicine. If you take medicine, there's more than 10% of medicine which is being sold, pharmaceutical products which are actually counterfeited. So that's a big issue, and there are people dying every year because of that. So our claim in the topic is really that if you combine the blockchain with IoT technologies, Internet of Things, sensors, tags, and you can put those on physical products, you can suddenly start increasing the quality of your data, increasing the traceability of products. So first you will be able to trace the origin of products, where they came from, when the products were made, how they were being processed, how they were being transported and stored. And the idea is really incorporate that on top of blockchain, because blockchain itself doesn't really know about the real world. So the key challenges that we still need solving, because we're not quite there yet, there are some key challenges, especially in the Internet of Things space and also blockchain, that needs to be solved. First is the fact that crypto fees, when you use tokens to pay for a system, if there is volatility, no big company is going to be able to use that because they don't know how much they are going to spend at the end of the month. So that's a very important first problem to solve. You want to make sure that a company using such a system, they know exactly, based on how many things they produce or move, how much they're going to pay at the end of the month. The second issue is that there's no single protocol for the Internet of Things out there today. There are like thousands, and that's a big problem. There's very limited interoperability. So when you read those crazy scenarios of smart cities, devices talking to each other, we're not there yet because of this first fundamental problem. How can devices understand each other at scale in a very decentralized and heterogeneous environment? The third issue, which is very much the limitations of current blockchain technology, you have very limited scalability, you have very limited performance. So you're not able to handle the 50 billions of devices sending data every few seconds out there. You cannot do all of that on current blockchain technology. Another issue is end-to-end security, because blockchain itself, it's nice, whatever you put in is guaranteed to stay there, but the problem is garbage in, garbage out. So you really need to work on ensuring that whatever data you're using for your decision making comes from a trusted source. And IoT systems today, most of them, they just use encryption, which is nice, but it's not sufficient. With most of IoT deployments and sensors on market today, you cannot mathematically prove that data really came from a sensor and hasn't been tampered with somewhere along the list. And the final challenge that needs to be solved is the lack of tooling. There are so many protocols, therefore there are so many frameworks and pieces of software, but it's very, very limited. And getting into the IoT space as a developer, if you want to take some devices, start to program them, you just need a lot of knowledge, a lot of expertise to be able to pull that off. So at Ambrosus, this is the company I work with, the project we're doing is called MNet, and we try to combine seamlessly, very efficiently, IoT technologies, sensor data with the blockchain. So the core project we're building, which is MNet, is essentially a decentralized backbone where companies, entrepreneurs, developers can suddenly start to integrate all sorts of devices, sensors, ERP systems, IT enterprise systems, printers, anything in the real world to be able to exchange data with each other, to integrate data from different sources in a very, very efficient way at scale. For that, one of the things we've been proposing is to use a universal data model. So very, very simple way to describe data, to describe sensors. What is this sensor? What is the data? What is the quality of the data I'm getting from this sensor? Can I trust it? So it's really a higher level abstraction model for developers, which is not just wallets, transactions, but really a higher level abstraction, which is assets, events. And I'll get to that in a second. The second thing we've been trying to solve is really the ability to support both public and private data. So just data encryption, as I mentioned, is not enough. Some companies are very, very scared of their internal data, their sensory data getting out there. So they really want to make sure that they're fully in control of their data. It can be stored in a very, very secure place. Maybe sometimes the data needs to be centralized for government reasons, for legal reasons. You want to make sure that the fees of using such a system are stable in US dollars or pegged to any fiat currency, so they know for a fact how much the system is going to cost at the end of the month. Our system is entirely governed by crypto economics, so all of the interactions, data upload, all the security checks is done on-chain via smart contracts. And finally, everything we're building is entirely open source, so you can head out to our site, start developing, testing around, so all of that is out there, and that's really important to be in the open source element, obviously because of the trust. If you're using something that's proprietary in the IoT space, you don't know how it works, you don't know how it's there, so you don't have the guarantee required. So if you look at a tech stack we've put together, so first we have the core blockchain. That's the core layer, the brain, the governance, if you want, of the system, which manages all the payments and things like that. On top of that, we've built a decentralized storage solution, something like IPFS if you want, which is fully integrated with the blockchain, where you can pay different actors to store data on your behalf, and they would get rewarded for it. And the third label, which is the most important piece in my opinion, is really all the SDKs, all the tooling, the APIs that allow someone to build very, very quickly, adapt on top of that without even necessarily having any blockchain expertise. So just to jump a little bit more in the tech of that, the technological aspects, how it works is that first we have this pentagon here, which is Hermes. That's basically the name we gave to that service. It's entirely open sourced, and essentially that is a gateway. On one side, it provides a very simple REST API for all sorts of developers to send data from devices or build an app that reads data. That is a centralized component which can be run and operated by any company in their own data center, or it can be used in the cloud, something like infra if you want. Now, what happens is you're storing all those sensor readings locally, but what happens is the Hermes gateway takes a snapshot of every single modification, every single entry you're doing there, and puts that in a bundle. So first, this is very, very fundamental because it's like an audit log of every single operation in your database. That gets put into a bundle. A bundle is essentially a huge file, 150 megabytes, that contains the metadata of every single transaction you've done in your Hermes gateway, and you upload that on the blockchain. So what happens when you do this is you pay a fee, which is stable, you pay it in tokens, but if the token price increases, you need less and less to store a bundle. The price of uploading a bundle is fixed, it's $12 US, and you can put around 15,000, 16,000 single sensor readings or any type of data you want to record in a bundle. Then the third step is you have this network, this distributed data storage network, which are Atlas nodes, and they essentially, their only role in the network is to download the actual bundle, the full file. Only a proof of the file goes stored on the blockchain in the transaction, but the Atlases download the file, they can verify if the file they downloaded is actually matching the hash of the bundle on blockchain, and for every single bundle, you pay the $12 fees, and that will be paid out to every Atlas node holding your data. And what's really interesting here is that it's incentivized on one hand, but on the other, Atlas nodes actively watch each other to make sure no one is modifying any data, because there is a reward for any node to say, hey, Atlas 24, he actually changed some data, and they earn as well, which means we as a company or as a project, we don't need to store, we don't need to monitor what the nodes are storing. All of that is handled inside the smart contracts. So just to finish, a very simple use case, it's one of the type of application that you can build very, very quickly on top of MNet. So first, this is a vaccine company who wants to send some vaccines. They want to transport it. So the first thing they will do at the factory, at the packaging line, for every single box of vaccine they create, they generate an asset. And an asset is essentially a crypto secure, globally unique identifier. Think of it like a wallet address, essentially for every single product, which has a serial number, and then the physical product itself is sealed with a tamper-proof RFID tag, so you can actually know if someone tried to open the bag, or if someone is trying to create counterfeit medicine, they won't have the digital identity that was created in the first place on the blockchain. So all those seals, all those vaccine packs get packaged together into a cold box. It gets closed at the factory, and inside the cold blocks you can put a sensor like this one, which is something we've built in-house. It's a very simple Bluetooth sensor which measures temperature, humidity, motion, light. It has a battery, and what's really interesting, and the reason we had to build our own sensors for that, is off-the-shelf sensors you buy, very few of them have actual crypto chips on it. So this works like a hardware wallet. There is a chip which contains a private key that is only available and generated in hardware on the device. So you have a way of measuring the box. If someone opens the box, if the temperature increases above a certain level, you have all of that is stored. And those are built in such a way that if you open the device or if you try to tamper with it, then it will get detected. And what's really interesting, once you put that cold box into a truck, that truck moves along. It can also have other devices inside the truck that read data from the sensor, forward that to the blockchain, and when it arrives at the pharmacy or at the doctor, they can pick the medicine, they can open the cold pack, and they are able to verify not just that the product itself is authentic, thanks to the asset, the unique digital identity, but they can also measure the entire conditions of transportation, which they can share with their patients or with any doctor who is buying one single pack. They can verify all of that. So, just to conclude, I think the key main points I was trying to convey is, first, current blockchain approaches and the idea that every single node must have all the data obviously is not going to scale, and especially not when you talk about IoT scenarios where you have billions of devices all over the world. Not all the data of every single sensor needs to be shared, but only a proof of that data needs to be visible and publicly accessible. So the best trade-off where you get both the advantages of centralized systems and decentralized one is where you have one single public chain, basically like the presentation before, where you have one single root chain, if you want, that is public visible by anyone, on top of which you can plug a variety of either private or semi-private chains where the data of all of that is centralized. So this combination of decentralized and centralized system is essential if you want to get the performance. The second aspect is really interoperability. So we need to find a single way to define, to describe data, to describe sensors, what they do, if you really want to build a global scale autonomous IoT systems that can be used in an ad hoc manner. The third aspect is the security level that is used in blockchain is essential. Very few IoT solutions, hardware devices use that today, and it's fundamental we start adopting the best practices that are in use in blockchain directly on devices as well. And finally, the most important bit is really the developer tooling. The easier you make for someone to build a hello world, to build a prototype, and then be able to scale that, that's going to be really a trigger point if you really want to build a truly global autonomous ecosystem. So thanks a lot for your time. Happy to take any questions, if any. Otherwise, I'll be around for next 2 days, so very happy to discuss. Okay. Any question? No? Good. Go to lunch. I'll see you around. Thank you.